Hello, and I have something a little different today. I've actually been looking at Reddit, and there is this post has access to a grid trading system, but doesn't have the code. So how do you write that? Now, there may be more to this than is described here, but I'm just going to take the points that have been raised and I'm going to write the code for it. But let's go through the key points here. First, opens both buy and sell trades with no stop loss and a take profit of 10 pips. So that's a fairly standard grid behavior. It simply opens in both directions at one time, and every trade has a take profit, but it's allowed to go into loss and will then make up that loss later. When prices move against by 20 pips, open a new position. So this again, fairly standard grid logic. If you open a buy trade initially and the price goes against you by 20 pips, you'll open another buy trade and 20 pips later another buy trade and so on. But then here it also mentions a martingale system. There isn't a description of how the martingale works. I'm going to assume one, and my martingale will simply have a martingaling factor, and I'm going to grow the position size exponentially according to that factor. There'll be more description of how that works when I get to the code. Finally, this closed the whole batch, losing side trades, including when it reaches a profit of 10 pips. So I'm taking that to mean that there will be an average price point, and when the price hits that, it will close all of the trades. Some of them will be in loss, some will be in profit. And if you add the profits together on all of them, then you've made a 10 pip profit on everything. There may be more details to this particular strategy, but the code that I'll write will get all of this covered. And then you can modify things like the martingale method. And if you want to change the number of pips for a take profit and so on. I will be setting inputs for the take profit of 10 pips and for that 20 pips distance between trades and for the martingaling factor. But I'm going to hard code the martingale calculation. So if you want to change that to something like a linear calculation, then you can simply modify that code. I think that's enough description of where we're going. It's not a very complicated piece of code, so let's just get in and do that now. Now I have opened the MetaTrader editor. This is the MetaTrader 5 editor. I have already created inside my Orchard folder another folder called mgrid and one there, or I've created the beginnings of the MQ5 file, mgrid.mq5. And in here, so far, I just have this header comment, three key properties, the copyright, link, and version, and then the onInit function with nothing more than the return init succeeded, the onDinit function with nothing there, and an empty onTick function. Now, I'll be jumping around a little because as I introduce functions, I'm going to be going to those new functions to write them. But to begin with, I need access to the cTrade class because that helps me to place trades, and it also gives me access then to the cPosition. So I'll include trade/trade.mqh. That's a class that's provided by MetaQuotes. And then that gives me the cTrade class, the cPositionInfo class, and I'm just declaring a trade and a position info variable for each of those. So I'll move straight on to inputs. And as I would have said in the introduction, the key inputs are what is the take profit pips, what is the gap between each trade in pips, and then what is a martingale factor. So I've added them here with the default values that I took from the original post. So 10 pips for a take profit, 20 pips before I open a new trade if the price is falling behind. And I've added in my own martingale factor here, and I'm just setting that to 0.2 initially. So obviously you can change that to anything you like. I've also included a little bit in the comment here to show how I'm going to calculate that martingale. So this 1 plus g, that's the growth factor, which is this number, and raised to the power n, that's the number of trades that are already existing. So if you have, say, 5 trades already open, you're about to open the sixth, then the size will be 1 plus 0.2, so 1.2, raised to the fifth power, multiplied by the initial volume. I'll also need an input for that initial volume, INP volume, that's 0.01, just some magic number that I've set up here. And then for the trade comment, INP comment, I'm actually making that a const rather than an input, and I'm just setting that to mgrid. Now, because I have these two inputs, take profit and grid size in pips, I'm going to want to convert those to a double value. So I'm going to do that just once at the beginning of the code and hold them in global variables. And these are my global variables, the take profit and the grid size. The first thing I do in onInit is assign this magic number to this trade object so that every trade that I make after that will use that magic number. Now I'm going to store these take profit pips and grid size pips in these two variables. And to do that, I'm using this pips to double function. That's a custom function. I use it quite a lot. So I'm going to go right down to the end of the code now and just add that function so you can see what we're doing. For my particular pips to double, I actually have three functions to make this work. I have the pips to double function, which just takes the symbol and pips, and then it calls this points to double function using that symbol again, and the result from another function, pips to points. So pips to points is the important one here. Pips to points simply says that if the number of decimals in the price is 3 or 5, then I'm going to multiply by 10, otherwise I'll multiply by 1. So if the price you're quoting has 5 decimals, then 1 pip is the fourth decimal. If it has 3 decimals, then 1 pip is the second decimal. And for anything else, then 1 pip is whatever the last decimal is. So that simply converts the number of pips into points by basically multiplying by 10 if it's a 3 or a 5 digit price, and multiplying by 1 in other cases. That gets passed into points to double. Points to double, which has the symbol and now the number of points, simply returns the number of points multiplied by, and this is a system function, system info double, the symbol and symbol point to get the size of a single point for that symbol. And of course, that all then comes back through pips to double, and that's done. And back to the beginning of the code, on DInit has nothing here, and I don't need anything there. Because this particular expert looks at trades on the buy and the sell side separately, so it will martingale up on the sell side and it will martingale up on the buy side. It will close everything at an average price on either side. I need to gather information about each leg, and one leg to me is either the sell leg or the buy leg. I'm actually going to create a structure to store the information. I'm going to put the structure right up here at the beginning of the code. So I'm going to call my structure cleg data. It will have a count, that will be the number of trades that are open on that leg, a tail price, which will be the worst price. So for a short side, for the sell side, that will be the highest trade price, and for a buy, that will be the lowest trade price. Then there'll be an average price, which is calculated value. Vol price is going to be the total of volume multiplied by price for all of the trades in that leg. And vol total is just the total volume for that leg. So back to the onTick function, I'm going to declare a variable for the buy leg and the sell leg of that type cleg data, and then I'm going to populate them. So just cleg data, buy data, and sell data, and I'm going to create a function called getPositionData where I pass in that buy data and the sell data. I'm calling this on every tick. It's not the most efficient thing to do because there are obviously not going to be changes on every tick, but I found that when I ran this, it didn't need a lot of resources, so I'm not going to worry about that yet. So I'll jump down now and create this getPositionData function. Now, the first thing I'll need to do in here is to initialize the values inside this buy data and the sell data. And rather than write the code to do that twice in here, I'm actually going to put a function inside the cleg data structure. And I forgot to mention earlier, when you finish the structure with this closing bracket, you must include a semicolon. So here's my init function, and I'm just setting all of the values to 0. Now in getPositionData, I can call that init function on each of these two legs. And then all I have to do is look through all of the positions that are open, check whether they're a position for this expert, and then call the appropriate buy or sell data to update for that information. So I'll put all of this in at one time, but I've introduced a number of functions here. To begin this, for I equals, or for int I equals positions total -1, I greater than or equal to 0, I minus minus, that's a standard loop to begin looking through all of the positions. But those positions may not be just for this expert, they may not be just for this symbol, so we need to filter those out. I have this function select position where I'm just passing in the position number, so that's a custom function, and let's write that one. I'm actually writing it as two functions. There is a select position that just takes the index. It calls select by index with just that index. So position info has an inbuilt function called select by index. And that will actually find that particular position. And if it doesn't, then something's happened and I need to just return false for that. So that means nothing was found. But once a position has been selected, I then need to check whether it's for this symbol and for this magic number, because that will tell me if it's for this expert. And I just use position.symbol and position.magic, compare those to the symbol and the magic number, and return false if either of those fail. And if I get to this point, I can return true. The other function, which we're not using yet, but I will need a little later, I'm passing in both the index and the type, and this type will be either a buy or a sell. And to do that, I'm simply calling the other function, the select position just by index. If that fails, then I've obviously failed and can just return false. If that passes, I've just added one more condition here, which is if the type is not equal to this type, then return false. And it's very important, I'm using .position type, not .type. If you use the sensing features inside the editor, you'll find that .type is a function, but it gives a very different result. And then return true. So now I've covered select position just by the index, and that will return either a buy or a sell, but it will belong to this symbol, this chart symbol, and this expert. And then I have a test. If the position type is a buy, then I'm going to update the buy data, else I'll update the sell data. I only have buy or sell in this expert, but this update, that's another function that I'm going to add to that structure. So back to the structure here. First the count, just adding one to that with plus plus. The vol price, I said that's the total of the volume multiplied by the price, so I'm adding to that with the plus equals. The opening price of that position multiplied by the volume of that position, because I'm trying to get a volume weighted average price. And the volume total then is just plus equals position info volume. The average price then, I'm recalculating this every time this update happens, and that's just the volume price divided by the volume total. And so that will give me a volume weighted average price for all of the trades that have been added so far to this structure. And then this tail price, though, that needs a little bit of extra logic, because if it's a buy position, as I said, and the tail price is either equal to 0, which means I haven't set one yet, or the opening price for this trade is less than the tail price, then I set that tail price to the opening price for the current position. If it's a sell, then I still have this tail price equals 0, but I've simply reversed this condition, position info.price open is greater than the tail price. And then I do the same thing, tail price equals position info.price open. So by calling update on this structure, it updates all of those values that I need to be able to run the code. So that finishes everything for get position data. And at the end of this, because these two have been passed in by reference with the ampersands, the buy data and sell data variables, the buy data and sell data variables back here in the onTick function will have all of that data. Next, I just want to get some information about the current price. I'm setting up a structure of type MQL tick. That's an inbuilt structure type, just calling it tick. And then I'm populating that with the system function symbol info tick, passing in the chart symbol and that tick. So at the end of that, that tick variable have the bid and the ask price, which I can use depending whether I'm in a buying or a selling mode. So let's deal with the buy side first. And this first condition is about opening a new trade. And I'm saying here if buy data.count is equal to 0, that's one of the conditions where I'll open a new trade. So if there are no buy trades open, I'm going to open one. Or if the ask price is less than or equal to the tail price, which is the lowest priced buy, minus the grid size. So I've gone that 20 pips below the lowest buy trade, and that means I need to open another trade. And I have a custom function, which we'll write very soon, open trade, passing in the order type buy, and that buy data because I need some of the information from that structure to open the trade. After I've done that, I call update take profit. And I'm passing in position type buy and the average price plus that take profit amount. So I'm calling this after the open trade because there may be trades already open. I want to add this trade that I've just created into the mix. I want to update the take profit on everything. And also when I call open trade here, I'm going to be setting the initial take profit on that trade to 0, but this update take profit will take care of assigning a take profit to that trade. And you'll see that the update take profit is outside this condition, so that is called on every loop of onTick. So just before I go and write the open trade and the update take profit functions, I'll do the same thing for the sell side. You can see it's all the same. Sell data count equals 0 or tick.bid, and here's one difference, is greater than or equal to sell data tail price plus the grid size. Then I open a sell trade and update take profit. Again, on position type sell, but here I've simply changed that sign to a minus sign. So we'll deal with the open trade first. Passing in the type, it's an enum order type, and the leg data. And this is the same code that I have earlier. I probably could have passed in the tick value, but I didn't bother. I'm just filling it in again here. It doesn't take much resource. So now I need to calculate the price where I'm going to open this trade. And the open price depends whether this is a buy or a sell. If it's an open type buy, then I'm opening at the ask price, else I'm opening at the bid price. And then I'm normalizing double. Probably don't need to because this ask and bid should already be valid prices, but it's safe to do this. Normalize double the open price for the number of digits, and that digits function returns the number of digits for the current chart symbol, and the chart symbol is where we're running this expert. And then I'm calculating the volume. This is the Martingale. It's the initial input volume multiplied by, and as I said in the comment earlier, 1 plus the Martingale factor raised to the power of data.count. That's why I've passed in this data here. So 1 plus the Martingale factor raised to the power of the number of trades that are already open multiplied by that input volume. Now, if you start with a very small volume like a 0.01, it may take several trades before you see any increase at all, and that's perfectly reasonable. And then I have this statement, normalize double, on the volume. If I take an initial volume of, say, 0.01, and I multiply that by 1.02 raised to the third power, I'll get a volume number that is an invalid decimal for creating a new trade. There are 4 ways to convert that to a valid volume. There's the right way, there's the easy way, there's the simple way, and then there's this way. This is a hack because I'm simply assuming that the symbol you're trading on has a valid volume of 2 decimal places. The simple way would be to have an input where you specify that number, and then I can simply put that input value in here. And then it's all up to you to know how many decimals you should round off the volume number to. And then the other 2 methods, the easy way, where you simply determine the smallest increment of volume, and from that you can calculate the number of digits. And then the correct way, where you actually also handle the initial minimum volume and the maximum volume. I'm not going to go into those here. I've just left this hack, but remember the simple way to get around this is to have an input for that number of decimals. If you don't do this, then you'll get an error trying to open any trades that don't have a valid decimal value for this volume. And then all I have to do is open the trade, and I'm using the trade class or the C trade class to do that, the trade object. So the trade object has this position open function, symbol, the type, which is this order type from that function call, volume from here, open price from here, and I'm setting both the stop loss and take profit to 0 initially, and then the comment, which you'll remember we set at the beginning of the code. That returns a boolean if the position open function was successful. If that's true, then I update the data object. The vol price, I add the result price from the trade multiplied by the result volume from the trade, and the vol total, I just add the result volume from the trade. And then I recalculate the average price as the vol price divided by the vol total. So after this function call, the data object that was passed in now also has information about the trade that was just opened. And now I can look at the update take profit function. Now I'm starting by normalize double on the take profit price here. I'm doing that because if I go back to the call, the take profit price that's being passed in is the average price minus take profit. And average price, because it is this calculation, may have, again, invalid decimals. So I'm just calling a normalized double here. And then I have a loop through all positions again. I'm calling select position, but this is the other form where I'm passing in the type because I'm only looking at either the buy or sell, depending which this has been called for. And then if the take profit price has passed in and normalized is not equal to the existing take profit price on that position, I'm going to update it. And I do that with trade.position modify, passing the ticket number, position info.ticket, the current position stop loss, which should be 0, but just in case something has been changed in the code, I'm passing in the actual stop loss that I got back from that position, and then the new take profit price. So I'm only calling this if the take profit price changes, just mainly to avoid unnecessary calls and possibly to avoid getting errors that the take profit price couldn't be changed because it's no different to the existing price. So that will just loop through all positions, find positions that belong to this symbol, this expert, and the correct type, and update the take profit price. And because I set the take profit price to 0 when the trade was initially opened, and then I'm calling update take profit after that, and on every tick, this will always adjust that take profit price for all trades. So all trades of one leg will have the same take profit price, which means that they will all be triggered to close at the same time. Now, triggering them to close is done by the broker. As soon as the close price for buy or sell hits that take profit price, the broker will begin to close all of those trades. But you can get some slippage because it takes a little time to close each trade. And it's possible that they don't all close at exactly the same price. Just expect that. And I think that is everything I need. Now, I'll just mention before we go and run this, there is very little error checking in here. So for example, in on tick, you probably should have conditions here to check that the market is open. There's no point in running this if the market's closed because you can't open trades, you can't close them, you can't even adjust them. So if the market is closed, I generally have a function, is market open? And if that returns false, I just get out of on tick right at the beginning here. There is also no check to make sure that the volume that's been calculated is not above the maximum volume or below the minimum volume. So there are a number of things here that you may want to add conditions for, but this will work in the test situation. So let's compile that and then go and run the examples. Now, I've set up to run a test with most of my usual settings. I'm using Euro USD to begin with. The time frame here is H1, but because this runs on every tick, it doesn't really matter what that time frame is. My custom period, typically 2 years from January 23 to January 25. I might move that forward later, but that's where we'll start. This is, because it has that martingale in it, it needs a reasonable amount of cash. So I'm setting a deposit of $2,000. I normally begin these with only a $1,000 deposit. And also because the zero point 0.2 martingale growth factor is quite aggressive, I've just changed it to 0.1 here in the inputs. So I'm going to run this for 2 years now, from January 23 to January 25, and see the results. So that's the result of the test, and it's a nice profit here. If I go to the back test, you can see a profit of 4,766 on a $2,000 deposit, but you will notice many of these very large drawdowns. And some of these, I think that drawdown is actually larger than the initial one here, could have destroyed the account completely if the account hadn't had time to build up this running balance as we go. And that's the danger of running a martingale type approach, that the trades grow so quickly that you can easily ruin your account. If you started somewhere around here, then it's a nice steady progression. So you would have had plenty of time for the balance to grow, but you never know when that's going to be. And for all you know, like here at the beginning, the drawdowns could have started on day one. There are several things you can do to reduce that. You can simply reduce the martingale factor. Now, reducing the factor means that the deposit load doesn't grow as quickly and the drawdown doesn't grow as quickly. But it also makes it harder to reach that point where you achieve the average take profit. So there's a bit of a balance that you need to strike there. And in fact, just with this model, if you set that martingale factor to 0, then all of the volumes are going to be the same as the initial volume. And so you've effectively got a simple averaging ladder. You could change the method that I'm using for calculating martingale. Remember, I said that I have an exponential method. You could make that linear, or any formula that you like to use that martingale factor to grow the deposit size. But the same things occur. If you have a smaller growth, then it's harder to reach the average price. but you also get a longer term to draw down. You could increase the distance between trades as the volume increases. So if the volume increases by 10%, you have a 10% increase in the distance between trades. And that may be a better approach for you. You can limit the maximum size of trade. That again, same influence. It will make it harder to reach the average, but it will slow down the drawdown. To go to a more complicated type approach, you could say that you're going to set the average take profit only on the trailing, say, 6 trades. So if you get to 12 trades, as soon as you get the average on the bottom 6, it will close those and then just keep working like that, going through 6 at a time. So that will allow you to take a profit earlier because you don't need to wait for the price to come all the way back to that midpoint before you close everything out. Um, but otherwise, this has operated with a reasonable starting balance of $2,000 and with a growth factor of only 0.1. Now, I'm going to run a couple of other tests here just quickly to see the difference. I've just changed the symbol to Aussie CAD because that is a much more stable pair. They don't diverge quite as much as Euro and USD. Otherwise, all of the inputs here are the same. These inputs are all the same. And the result here, you can see we still have these drawdowns, but although they look quite large until we get to the end here, they are much smaller than the euro. They look large because of the scale on this chart. And then we've got a very big drawdown in June 24, but it does recover. The overall profit is less than we had from euro, but slightly less risk. So you can see that simply changing to pairs that are more closely aligned is better for this type of grid strategy. Now just one more test. So for this final test, all the inputs are still the same. I've gone back to Euro USD and I've simply added one more year. So now I'm running from January 22 up to January 25, so a 3-year test. Everything else is the same. And the result here, at the end of 22, if I just eyeball this with the grid lines, 2022 ended around here. That grid line comes across. So that's about a $5,000 profit just in 2022. Now, 2022 was a very volatile year, but it was volatile with retracements, which works well for this type of grid because the retracements are what allows the price to reach those midpoints or those average take profit points and close out the trades. It's when you get a movement, and it can be a slow movement, but if it never retraces, then you just set more and more positions. Even with that, you can see that the deposit load has reached around 10% here in the early stages. So altogether, this is risky. I will put this code available on the website for you to download, and there'll be a link in the description of the video where you can find that. I hope this has been useful to you. If it has, remember, click that like button because it helps people to find the channel and get some value from it. It also helps me to get some views and pay the costs of running this. And if you want to see more of these videos, then click subscribe and click the bell icon to be notified when next videos are released. Thank you for watching.